Okay, guys, I'm going to be going over lesson 2.6, completing the square. Again, that's this one here. These are the problems that are listed. Again, remember that the delta math problems are solved just a little bit differently than these, but the ones that are in this packet, this is what I'll be going by as far as like how I expect it to be done in the quiz. Okay, so remember again, as always, these are obviously not your problems. I created new ones so that you can kind of follow along. Okay, so first off, as we work through all of these, the idea is that we want to identify if it's a circle or a parabola. So we want to figure that out before we figure out what method we're going to use, because you're going to take the similar approach and using completing the square, but the couple steps are just a little bit different, or done a little differently. Okay, so here in the first one, for each quadratic function below, use the method of completing the square or averaging the x-intercepts to rewrite the equation in graphing vertex form. So remember, graphing vertex form is y equals a times x minus h squared plus k. Okay, so that's that vertex form or graphing form. It's kind of the same thing. That way we can get the vertex from h and k. And then also the line of symmetry, which is what the LOS stands for, will just be x equals h. All right? Okay, so let's go through these. So first we're going to use completing the square here. So to complete the square, I'm going to rewrite this, but with space after the 4x, because we're going to be adding a number here. And I'd like to actually put a little square just to remind myself of what needs to be added or subtracted. I know when you guys watch the video, Miss Menard, she just kind of wrote a number there, but I like to put a little square. Okay, so I still have this 11 out here. So whatever I add to this equation, I'm going to have to end up subtracting as well. Because remember, when you're dealing with equations, you got to make sure it stays balanced, right? Notice how the equal sign is over here. So if I add something to this side, that means I also need to subtract that same number so that it stays balanced. So I'm not really like changing the equation. I'm just putting in some new terms. Okay, so again, I take that, look at my middle term to complete the square, and basically I take that number, which is b, divided by 2, and then square it. So all I'm doing is I'm taking half of 4, dividing that by 2, which is 2, and then squaring that. So 2 times 2 is 4. And then what I have to do is subtract that 4 as well. Now, what you are basically essentially doing next is, after you complete the square, what this is giving you is a very easily factorable trinomial here. So you could like set this up with the x and put 4 on top, or 4x squared, 4x down here, and then figure out those two numbers that multiply the 4 but then add up to 4. Well, that's 2x and 2x, right? Now here's the deal with completing the square. The nice thing is that it's always going to work out the same way. So it's 2x and 2x. If I do the box, I essentially end up with x plus 2 times x plus 2 after I work out all those steps. And then over here, we'll just simplify that, 11 minus 4, which is 7. But remember, if I have 2 of these factors that are written like this, I can write that as x plus 2 squared. And then plus 7 over here. Don't forget your f of x or y, depending on what the problem started with. Okay, now the line of symmetry, remember I told you it's just x equals h. If that's plus 2, then that h value is actually minus 2. And so the vertex is minus 2 and then 7. Okay, so now on this one, same thing. Let me set this up over here. Leave a little space and write my little square because I'm going to plug in my number there. And I have 3 on the outside. And then I'm going to subtract whatever I add. Okay, so now half of, basically remember, b over 2. So I take half of this number, which is 4. Or negative 4, actually. It's half of that is negative 4. And then square that, negative 4 squared is 16, positive 16. And every time you complete the square, this number is always going to be positive because you're squaring it. Okay, so now I'm going to jump ahead. I know, just like I said before, these will always be the same, right? And all I did was, after I did the x, is essentially I took half of this number. So half of your b is that number there. So half of 4 is positive 2. Half of negative 8 is negative 4. So all I got to do is when I go to that next step is take half of that number and put it right there. Squared, and then simplify 3 minus 16, which will be negative 13. Okay, there's my equation. Okay, line of symmetry, x equals h, which is positive 4, because remember, x is a liar, you switch it. Okay, and then your vertex is 4 and negative 13. Okay, so now on this one, same approach, except just remember that you don't have a c value here, it's 0. So I don't really have to, I gotta just be mindful of that, but it's the same thing as these ones, it's just there's no number. There's no number, it's just 0, okay? So here again, minus 4x plus your square that you're going to use, plus, sorry, not plus, because in this case it's only 0 there, so I'm not writing another number, so I'm just subtracting whatever I added. All right, so now I take half of 4, negative 2, and square that, I get positive 4. So I'm both going to add it and subtract it. And then I just take half of negative 4, so minus 2 squared, minus 4. Pretty simple, right? Once you kind of get the hang of it. Okay, don't forget my f of x here. Okay, so then the line of symmetry will be positive 2, since that's negative 2. And then vertex is 2 and minus 4. Okay? Okay, so now, if you notice, all of these, again, it said quadratic function, so we already know that these are parabolas. And the key giveaway for a parabola is that all you have is an x squared term. X squared term, so that's a parabola. X squared term, so that's also a parabola. But now when we come down here, first of all, we already know that these are circles because they literally ask you what are the center and radius of the circle, but what's the key difference? The key difference is that there's like a y squared piece, like Ms. Menard was saying, and an x squared piece. So we know these are all circles. Matter of fact, why write that on each one? I'm literally just going to do like a little bracket like that, just writing that these are all circles, okay? And then maybe we'll do that up here too, saying that these are all parabolas. Because that's going to be key when you have to solve these, because eventually I'm just going to give you an equation, and you're going to have to figure out, is it a circle, is it a parabola, and then do the method to rewrite it in the right form. Okay, so that you can actually graph it and use it, and it becomes applicable. Okay, so now again, this is a circle, so that means we got x squared, y squared. Again, look here, x squared, y squared, x squared, y squared, y squared, and then look here, we got an x squared that's just in parentheses, right? Okay, so here, we got to remember that the equation of a circle, like Ms. Menard reviewed, is x squared plus y squared equals your radius, or equals 1. That's the parent function, right? So that number that the radius comes from goes to the right of the equal sign, okay? So here's the x squared piece is over here to the right, this x minus 3 squared, and then the y squared piece is on the left. So if I'm looking at the equation as sides, on the left, I need that x squared piece and the y squared. And that number, the constant, can stay over here. So what I'm going to actually do is I'm literally just going to add this whole part, x minus 2 squared, to both sides. Essentially, I'm just moving it. I'm just moving it over to the left. So now I get x minus 2 squared. And I always want to start with my x squared first. It just helps me remind me like that that's the x value of the vertex or center in this case. Not vertex because this is a parabola. And then plus y plus 2 equals 16. Okay, so now my center, x is a liar, so that's positive 2. And then you also treat this like x is a liar, but in this case, it's y is a liar. So anytime it's like in parentheses like this, you treat it like it's a liar. Here in vertex form, parabola or graphing form, it's outside the parentheses by itself, the constant, so you don't change it. So anytime it's inside those parentheses, you want to change it. So here, that y value is negative 2. And this is why it's important to make sure that the x goes first and the y part goes second, so you don't get these two mixed up. Okay, so then our radius, remember, is the square root of that constant value here. So basically I take the square root of 16, and so the radius is 4. Okay, so now here, same thing, except it's not arranged properly. we want to end up in this form where we've only got one x squared piece and one y squared piece. But what you notice here is that we have an x squared and an 8x. So we're going to have to use the complete square steps to get in that right form. Now, in your version, you have the y, but you're going to do the same thing. It's just I'm going to show you how to do it with the x. Okay, but it's the same steps. Okay, so here, the good thing is that on this one, I don't have to do anything with the y squared. I don't have to like complete the square with that, but I do need to complete the square with the x because I have this 8x term. Whereas in your version, you have to complete the square with the y. Okay, all right, so now x squared plus 8x plus my square that I'm going to add, right? Okay, plus y squared. The good thing, remember, it's just y squared by itself, so I don't need to complete the square, equals 9. And because I'm adding to the left side of the equation, I'm also going to add to the right. So this is where some of you guys might get a little confused. You're like, wait, how come we added here, but then subtracted here, but then here we add on both sides? Well, now look at it. Remember where I told you the equal sign, knowing where the equal sign is really important. Notice that we're adding and subtracting on the same side of that equal sign. So because we're doing this, adding these numbers on the same side, they need to basically equal 0. So 16 minus 16, 0. 4 minus 4, 0. 4 minus 4, 0. Like, you can't just add 16 because it won't be balanced. Okay? Whereas here, if I add it to the left, I also add it to the right. Okay? So now let's complete the square. So remember, 8 divided by 2, basically doing this again, is 4, and then 4 squared is 16. So I add 16 here and here. Okay, so now what I'm going to do is factor that just like I did up here. Okay, and again, the shortcut here is that I just take half of that b value. So I get x plus 4. And pay attention to the sign. If that's plus, make sure that's plus. Whereas like up here, it was minus 4x, so we put minus 2. Okay, so then plus y squared. And then 9 plus 16 is 25. Okay, so now it's in that circle form. So now the center, here, remember, x is a liar, minus 4. And because it's just y squared by itself, it's 0. So anytime it's just x squared or y squared by itself, it's just 0 for that value. Okay, then the radius, again, I take the square root of that value, which the radius is now 5. Okay, so then that way I have enough information to actually graph it and make a sketch of it. Okay, so now here, same idea, except I've got some more values to deal with here, and now I've got an extra x term and another y term. So the key here, though, is you want to get it arranged in the right order so that you can start completing the square. Okay, so here I want to put the x's together, x squared plus 6x, and I'm going to be completing the square, so put your little square after that, and then I'll enclose that in parentheses so that you know that you're just working with that part alone. And then plus the y squared. Now I'm going to put all the y's together, plus that square that you're going to complete. And then also what I want to make sure I do is keep the constant on the right side. So here I'm going to add that 21 to both sides of the equation. And the reason I'm adding is because that's negative, so I add it to both sides. Whereas here you have a 47, so you would subtract that from both sides. Just pay attention to what the sign is if you have to move it. Okay, whereas in this case, notice that constant was already over here, so I didn't have to like add or subtract 9. Whereas here, it is on the left side, it needs to be over here to the right. Okay, so I get 21 here. And then I do need to account for the fact that I'm going to add a complete square here and again here. So I'm going to add both of those twice. So again, half of 6 is 3. Square that is 9. So I add 9 both sides. And then half of negative 4 is negative 2. If I square that, I get positive 4. Okay, so now, again, I'm going to quickly do a quick shortcut to factor. I just take half of the b, so that's x plus 3. And then half of that b. So remember, this is negative 4, so half is negative 2. You want to make sure I pay attention to that negative there. Okay, so now 21 plus 9, that's 30, plus 4, 34. Okay, so now I want to list out the center. Center in this case is -3 since that's +3, and it's +2 since that's -2. And then the radius, well, notice how up here it was 16, right? And then 25. Those are perfect squares. So if I take the square root, I get a whole number. That's not the case with 34. So literally, it's the square root of 34. And then what I'm going to do is I'm going to use my calculator or Desmos or whatever you want to use, your phone. And I'm going to just write the decimal value, so 5.8. Because even if it's not a perfect square, you still need to graph it. So I want to give the decimal answer so that'll make it so I'll at least know where to put the limits of the graph. Okay, so there's my center and radius. Okay, now this one, again, make sure that you arrange it correctly. I want the x terms first and then the y terms second, right? Now this one, it's already factored and it already is in this form where it's the y minus 3 with the square. So I don't have to do any of the completing the square steps. I just have to rearrange this. Okay, so I'm going to switch these basically. They're on the same side of the equation already, so I don't need to like add or subtract it. I'm literally just putting one in front of the other. Okay, and again, it's important to put the x first because when you write out your center, you need to remember that the x value of the center comes from that. And remember, like I told you up here, if it's just a y squared or x squared by itself, it's just 0. And that's -3, so +3 here for the center. Okay, and then again, the radius will be the square root of that constant to the right, so the radius is 2. Okay? All right, so this last one down here in the bottom. All right, so now we're going to rewrite. So we're going to make sure that we have it in the right graphing form. And then we're going to sketch it and then label the important points. Okay? So first, let's identify it, because you notice it doesn't really tell you whether this is a circle or whether it's a parabola. Well, right away, I notice x squared, y squared, so we know it's a circle. So then I'm like, wait a minute, it shouldn't say vertex then, because vertex is for a parabola. So I'm actually going to just change this to center. Okay, and then we know it's a circle, so we'll write circle here. But then in order to graph a circle, we also have to know the radius. So we'll write down radius under here, just to remind us that we need to find it before we put it on the graph. Okay, so now let's rearrange everything. So it looks like x squared is by itself, but we have 2 y terms. But we have this constant here, so we need on the left side, so we need to add it to the right. Okay, so now x squared plus y squared. I'm only going to have to complete the square with the y. So I'll add the square right after the 4y. But then remember, I need it also on the other side. Okay, so half of -4, -2, square that, you get 4. Added that to both sides. And remember, I need to factor that. And when I factor it with the x in the box, the shortcut is just take half of that b value. So it's -2. And again, remember, pay attention to that negative sign. If it's negative, put negative. Positive, put positive. Okay, 13 plus 4 is 17. Okay, so now I should be ready to figure out the center, which is at x squared by itself, so that's 0. And then +2 there. Okay, so that you know right away that's a y-intercept too, because it crosses the y axis. Okay, so then I need to do the square root of 17 to get the radius. It's at 4.1, so about 4. I'll put 4.1. Okay, so now I'm ready to graph. Okay, so when I graph, I need to just pay attention to my radius and the center to make sure I draw the right scale. Because if I got some really big numbers here, then I probably want to increase the scale. But it's, it's just 2 and 4, so I think we're okay with just going by ones here. As a matter of fact, it's a sketch. I'm just going to actually just go by 5s, make my life a little easier. So I know that first, let's draw where the center is. So 0, 2. So it's up on the y-axis right there. And I know that I'm going to have to go 4 in every direction. So what I'm actually going to do, this might be helpful to you guys, is I'm going to draw like these little lines, almost kind of like lines of symmetry, because, if with the radius, I go 4 to the right, 4 up, 4 left, 4 down. So here, I'm going to go 1, 2, 3, 4 to the right. Because, I mean, it's 4.1, but really it's 4. Okay. We don't need to be extra picky here. So 1, 2, 3, 4 to the left. Okay, and then I'm going to go up 4 from the center. So 1, 2, 3, 4, and then down 4. 1, 2, 3, 4. Okay, so now that's enough info to be able to make a little circle. Just do your best to sketch it out, and there you go. Let's go back up. Okay, let's move ourselves up here. Okay, so now, again, same thing. It says, what are the x-intercepts and the y-intercepts and the vertex of this equation? Sketch the graph and write an equation in graphic form. So first of all, right away, notice that it is only x squared by itself. So that means parabola. So just keep note of that. So being a parabola, one easy thing to find in standard form, we have A, B, and C, is the y-intercept is right there. It's that last term. Okay, as long as we're in standard form. So y-intercept's at 0, 60. Okay, and again, when I'm about to go graph, keep that in mind that 60 is a big number, right? So I can't just go by ones on it here. I'm probably going to go by like 10s or 50s or something like that. Okay, so now next thing we need to find is, we found the y-intercept, but we also need to find the x-intercepts. Okay, so to find the x-intercepts, actually, you know what, let's start with the vertex. Let me go to the vertex so that we can kind of continue on from what we did on the last page. So let's go to the vertex. Okay, so the vertex can be found in graphing form, but this is standard form. So what I'm going to do is we're going to change the form to find the vertex. So just like we did, again, remember it's a parabola. Sorry, that's going blurry a little bit there. Let me lock that. Focus. Sorry, guys. There we go. Okay, so it's a parabola. So remember, like we did in the very first problems, we're going to complete the square, add the square, and then subtract the square since it's on the same side of the equation. It's on the opposite sides of the equation. Okay, so plus 4x. Okay, and then plus the square. Okay, and then I got minus 60 over there. So, and then I'm also going to have to, subtract that same square. Okay, so now here, if I complete the square of 4, it's divided by 2 squared, that's 4. And I also have to subtract the 4. And then I do the quick factor here. Just take half of the b, x plus 2, and then I got negative 60 minus 4, which is minus 64. Okay, so there's our vertex. The vertex is negative 2 and minus 64. Okay, next step is to figure out the x-intercepts. Okay, so x-intercepts are the same thing as trying to solve this. So what I want to do is we're going to set this equal to 0. And we're going to solve. Okay, and we're going to use the x for that. So I'm going to put minus 60 up here. Sorry, 60x squared, because remember it's a times your c. And then 4x on the bottom. And I got to figure out those two numbers that are going to multiply up to 60, but add up to 4. Now some of you are like, oh man, as soon as I get to bigger numbers, it's hard to find those numbers, right? So here's a way to help you out. Start with what numbers will multiply to the number to the top. Start with that. And then we can figure out what adds up or subtracts to get 4. Okay, so I'm going to start with just 1 times what number is 60? Well, 60. Then 2 times what is 60? 30. 3 times what is 60? 20. And then 4 times what? It's 15. Okay, and I'm just going to keep going until I run out of numbers to multiply. Now, the easy way to figure out that number, because it's easy to list out 1, 2, 3, 4, 5, 6, and maybe we'll stop there and see if we have it. to figure out this number, just take that number, let's say 2, and divide 60 by 2, and you get 30. Divide 60 by 3, you get 20. Divide 60 by 4, you get 15. Divide 60 by 5, and you get 12. Okay? Okay, so, and then let's say 6 times 10 to get 60. All right, so from those, let's see, do any of those add or subtract to get 60? Well, there's no way that's going to work. They're not even close. Or that, or that. The difference between those numbers is not even close to 4. The difference between 12 and 5 is 7, so no. But the difference between 10 and 6, that's 4. So that should work. So I'm going to put 10x here and 6x here. But then one of them has to be negative. In order for that to be positive, the smaller number needs to be. Okay, so now you can use the box to figure out the factors, but I'm going to do some quick work of that because I know that when I only have a 1 here, I can go straight to this. Okay, so x plus 10, x minus 6. The only time you can't go straight to this from the x is when you have a number bigger than 1 right here. So if you got like a 2 or a 3, you really have to do the box. You don't have a choice. Okay, so then my x-intercepts are going to come from positive 10. So x is a liar. It's negative 10. And then x equals 6. So really my x-intercepts are negative 10, 0, and 6, 0. All right, now I've got a y-intercept, vertex, x-intercepts, ready to graph. All right, so I have to go, the vertex is all the way down to negative 64. So I think what I'm going to do is we're going to go by 50s. So I'm going to go negative 50 here, and negative 100 here. Again, it's a sketch, doesn't have to be perfect, right? So we'll do that all the way around. So 50 here and 100, same thing there, same thing here. Okay, so now first I'm going to start with the vertex because that's the middle of our graph. So negative 2 and negative 64. So a little bit to the left here and then down past 60, probably about there, right? Okay, so then that means my line of symmetry would go straight up this way, straight down that way. Okay, so x-intercepts are negative 10 and 6. So you know what I'm actually going to do is I'm going to use 2 different scales. Because on the x-axis, I only have to go over negative 10 and then to the right 6. So I'm going to go by 5s on the x-axis. I can go by a different scale on the y compared to the x. Nothing wrong with that. Okay, it just makes it easier for me to graph. So I know that I have to go all the way to negative 10. So there's the x-intercept, and then all the way to positive 6. About right there. Okay, and there's my vertex. Last thing I want to graph is that y-intercept. So it's like literally right next to that point. Okay, and just do a quick sketch. There you go. All right, so now you guys do it with your problem there. Okay, so now, again, complete the square to rewrite this in graphing form. Again, all I've got there is the x squared, so I know I got a parabola. All right, so complete the square with the left side. I'm sorry, not the left side, we're all on the right. Okay, so we're going to complete the square with the x terms. So remember, I'm going to add a square. Since we're in a parabola, I'm going to add it and subtract it from the same side. Okay, so half of negative 8 is negative 4. If I square negative 4, I get positive 16. So I'm going to add 16, subtract 16. Okay, and then again, the shortcut to factoring this is just half of that. So x minus 4. And then 5 minus 16, that's going to be, what is that, negative 11? All right, and then it says state the vertex. So my vertex is positive 4, negative 11. Okay. All right, so now this one, change the equation to graphing form. Well, notice here, x squared, circle. All right, so looks like I already have my x's together, my y's together. So what we're going to do is we're just going to expand it out a little bit so we have room to write our squares, or completed squares. So x squared plus 6x plus the square. Put that in parentheses by itself. And then the y squared plus, oh, sorry, not plus, minus. It's minus 10. Minus 10y plus the square. Ooh, I'm jumping onto my graph here. This is important that I think even Miss Menard mentioned it. You really need to have room to do these problems. So you really want to make sure you keep that in mind when you're working this out, especially on paper, okay? Or in the packet because you're really limited. So I got to add twice here, so I added twice on the right side. So remember the difference. If you're doing a parabola, you're adding, subtracting the same side. Circle, you're adding to both sides. All right, so complete the square with 6. I get 9. 9 both sides. Complete the square with negative 10. I get 25. Sorry, guys, it's hard to see there. That's a 25. And then add 25 here. Okay, so let's do the quick factor of this. Half of the 6, positive 3. And then half of the negative 10, minus 5. And then 2 plus 9 is 11, plus 25 is 36. All right, so since we know this is a circle, we need the center and the radius. All right, now the center is going to be negative 3, since that's positive, and positive 5, since that's negative. And then remember, we take the square root of the constant, so radius is 6. So what I'm going to do is, first I'm going to graph the center, negative 3 over 3, then up 5. Put that there, and then I got to go 6 all the way around, right? So I got to go 6 down, so this is 1, 2, 3, 4, 5, 6, so about right there. And I got to go over, actually we'll go up 6 to go the other way. I know that this is again why it's important to leave room for this problem. At least you guys can start your longer part of the problem up here, and you'll probably still have room. It won't get in the way. So 1, 2, 3, 4, 5, 6. So up there. And then 1, 2, 3, 4, 5, 6 to the left. About right there. And then 6 to the right. So 1, 2, 3, 4, 5, 6. Right there. And then there's my lovely circle. Isn't it beautiful? All right. No, it's not really, but it's okay. Try my best. Okay, same thing. Complete the square. Okay, there's x squared, so we know we got a parabola. Only x squared. And then here we got x squared and y squared, so that's a circle. So we know what we're graphing here. All right, so here, again, complete square on only this side. So we're going to add the square. And subtract the square. So half of 2 is 1. 1 squared is 1. And then add the 1, subtract the 1. Do my quick factor, which is half of 2 is 1. So x plus 1 squared, and then 5 minus 1 is 4. Okay, so again, to graph of the parabola, in this case, we need the vertex. The vertex is negative 1, 4. We also have a y-intercept. If you remember, we're in standard form already. So my y-intercept is 0, 5. Okay. And then what am I going to do to figure out the x-intercepts? Well, the thing is, if I try to do the x with this problem, because to find the x-intercepts, I would need to set up the x, right? That's what we usually do. So I put 6 on top, or 6x squared, and then 4x down here, and figure out 2 numbers that multiply to 6, but then add up to 4. Well, that doesn't work. So guess what? Quadratic formula. Okay, so to find the x-intercepts in some of these problems, you're going to need to do the quadratic formula. Okay, so what I'm going to do is I got my a, which is 1, b is 2, 5 is your c. Okay, so what I'm going to do is set this up. So x equals negative b, so negative 2, plus and minus the square root of b squared, so 2 squared, minus 4 times your a, which is 1, times your c, which is 5, all of that over 2 times your a, so 2 times 1. So what I'm going to do is I'm actually going to just use Desmos the calculator to figure all that out. So I don't have to work out all the steps. So first, I'm going to click that fraction button right there, and then I'm going to put the numbers on top. So -2. I'm basically just typing it out or copying it. So remember, first we have to add it and then subtract it. So first, I'm going to start with adding the square root of 2 squared. I know you guys know that's 4, but I'm just kind of making the point here of how to set it up. And then 4 times 1, again, all I'm doing, guys, is copying what I wrote down. So you can just look at your packet or rewind the video so you can see what I'm copying. All right, and notice it says undefined. Well, what do I do with that? Well, let me show you what that means. First of all, inside the square root, if I did 2 squared, let's say I do 2 squared, right? That's 4. And then I multiply this out, so 4 times 1 times 5, that's -20. And then 4 minus 20 is -16. So basically, I would end up having to take the square root of a negative number. Remember, that's a complex solution or an imaginary number. So here's what happens in these cases. So if I graph vertex 1 over 1 of 4, notice how I get a positive a value, right? My first number is positive. That means this graph is going to go up, right? So at 0, 5, that's the x-intercept right there. And I'm going to do a little axis of symmetry to kind of, help us draw out some points. I don't know if you guys remember a while back that if you have a 1 point on the axis of symmetry on one side, you can reflect it right over to the other side. So I'm just going to reflect this straight across. And this thing is going straight up. And this is why you get complex roots or imaginary roots, or why you got undefined when we type this, because it doesn't have any x-intercepts. It doesn't even cross the x-axis. It doesn't touch it. So there's these imaginary roots that are kind of like suspended in space. It doesn't have a root down here. Okay, so that's why you end up with undefined when you're going to look for those x-intercepts. Okay, so now the next one. Okay, so make sure it's a range, x terms, y terms, they are. So now let's just expand it out. So plus the square, put that in parentheses, and then the y terms plus the square, and on the right side, -4 plus both of those squares. Okay, if I complete the square root of -8, I get 16, add 16, complete the square of 4, I get 4, so I got 4. So now here, I'm going to have x minus half of that, so 4. And then y plus half of that, so 2. And then add all that together. -4 plus 16, that's going to be 12, plus 4, that's 16. All right, so again, we already knew we had a circle, so we need the center and the radius. So the center will be 4 and -2. Remember, again, you got to switch that sign too. Switch them both. It's just when it's in this form, you only switch the one inside the parentheses, not the one outside. And then the radius will be the square root of that number, so 4. So again, I'm going to go and graph it. 1, 2, 3, 4, and then down to 1, 2, and I got to go 4 in all directions. So I'm going to go, let's go 4 to the left. That's right there. 4 to the right. 1, 2, 3, 4. It's right there. Go up 4. 1, 2, 3, 4. And go right there, and then down 4. 1, 2, 3, 4. Go right there. Okay. I know it's not perfect, but don't hate me. All right. That's it.